Long ago, in a distant era, Earth resembled a vast tropical paradise. Warm seas near what is now the Arctic teemed with crocodiles, while Antarctica and Australia formed a single landmass. Colossal beasts, dinosaurs, roamed most of the continents. They thrived, then vanished abruptly. Scientists call this the Cretaceous-Paleogene extinction event, popularly dubbed the dinosaur die-off. But what exactly unfolded? Around 66 million years ago, at the boundary between the Cretaceous and Paleogene periods, roughly 1/5 of all species on the planet disappeared in a geological blink. This included about 16% of marine life and 18% of terrestrial creatures. It might seem modest. After all, 200 million years earlier, the Permian-Triassic catastrophe wiped out nearly 60% of species. Yet even this smaller loss reshaped every ecosystem. On land, no medium or large animals survived. For millions of years afterward, nothing longer than a meter existed. Ecosystems eventually rebounded, on geological timescales, that is, but the dinosaurs were gone. One could argue dinosaurs persist today. Birds descend directly from Archaeopteryx, the pioneering flyer among them. Crocodiles remain close kin, but the massive Tyrannosaurus rex, agile velociraptors, enormous plant-eating Diplodocus and Brachiosaurus, and ocean-dwelling plesiosaurs, all extinct. How did we uncover this disappearance? It started in the late 18th century with a bold notion from Georges Cuvier. He proposed that species could go extinct entirely. Before him, the world was seen as unchanging, fixed since divine creation. Cuvier challenged, what about the flood? Could things have been different beforehand? He rejected evolution, viewing history as divine creations interrupted by catastrophes. His framework faded during his lifetime, paving the way for Charles Darwin's 1859 masterpiece, On the Origin of Species. Darwin's ideas unified fossils into an evolutionary narrative, guiding paleontologists. Yet Cuvier's catastrophe concept lingered, sparking a century-long debate. Darwinism gained ground. From the mid-1800s to mid-1900s, gradual extinction via competition was favored. Theories abounded: flowering plants releasing toxins, mammals raiding eggs. Experts multiplied hypotheses like species. Ironically, for dinosaurs, Cuvier proved right. The shift came in the 1970s with iridium. In 1973, the Red Queen hypothesis emerged. Species must co-evolve with their environment or perish. Stable ecosystems saw about 5% of species in decline. Dinosaurs simply lagged, case closed? Not quite. In 1977, Luis Alvarez detected iridium, a metal scarce on Earth's surface but abundant in meteorites, at the Mesozoic-Cenozoic boundary in concentrations hundreds of times normal. The following year, 1978, a Mexican oil firm uncovered a massive anomaly on the Yucatan Peninsula, a structure over 150 kilometers wide, extending into the sea, dated precisely to the iridium spike. Science resisted at first, but global evidence from North America, the Soviet Union, Australia, Africa, coalesced into a cataclysmic story. Alvarez's asteroid impact theory solidified. Yes, an asteroid struck, carving the Chicxulub crater, but it wasn't alone. Around 72 million years ago, sea levels plummeted nearly 200 meters, stressing oceans. Climate swung wildly. Average temperatures hovered at 25 degrees Celsius. But between 68 and 66 million years ago, drops of 10 degrees Celsius occurred multiple times, rebounding swiftly. 500,000 years before the boundary, India's Deccan Traps erupted. Vast lava floods covered millions of square kilometers, spewing ash and gases. Volcanic winter ensued, chilly, acid rains, ocean acidification. Ecosystems reeled but might have recovered slowly. Then the asteroid hit, over 10 kilometers across. Billions of tons of crust vaporized into ash and soot, blanketing the globe. Tsunamis ravaged coasts. Re-entering debris superheated the atmosphere to oven-like temperatures for minutes. Shock waves ignited volcanoes worldwide. Paradise turned infernal. Scorching air, sulfuric rains, wildfires, perpetual twilight under smoke. Biblical in scale, yet prior woes amplified it. Oceans relied on phytoplankton, tiny base of marine food webs, feeding zooplankton, then fish, krill, jellyfish, mollusks, predators like ammonites and plesiosaurs. Pre-impact crises nearly eradicated phytoplankton. Productivity collapsed. Chains broke. Survivors, some cephalopods, nearshore amphibians, turtles, crocodiles. Lingering mosasaurs or plesiosaurs succumbed to final acidification. Land differed. Climate stress spurred specialization. Flowering plants symbiotically with insects, grasses forming turf. Days belonged to cold-blooded giants, nights to small mammals. Dinosaurs dominated mid to top tiers. Mammals scraped bottom. Impact targeted vegetation. Years of darkness killed most plants, starving herbivores. Giant sauropods died first, then large predators, mid-sizers. Small theropods lingered but lost to competitors. No flight like birds, no warm blood like mammals. Birds and mammals survived, 90% loss, but thrived post-crisis. Decades later, Earth cooled but regenerated. Seeds sprouted in dim cold, niches abounded, winners. Bony fish, once minor, now dominant. Mammals, from shadowy nocturnals to apex in 100,000 years. Diversity explosion, size growth, specialization, us. Birds, dinosaur survivors. Flight and small size propelled 10,000 plus species today. A million years on, life teemed anew. In a cooler world, sans giant reptiles. The Cretaceous-Paleogene extinction chained crises. Volcanism, climate shifts, asteroid. Life endured, as after prior mass die-offs. Dinosaurs won't rule again, but their avian heirs soar among us.